Today we're doing midterm physics problem 13. This problem says an airplane moves 140 meters per second as it travels around a vertical circular loop, which has a 1 kilometer radius. What is the magnitude of the resultant force on the 70-kilogram pilot of this plane at the bottom of this loop? So we put this into a free body diagram. We have the force normal and the force gravity. Force gravity is pulling the plane and the pilot down. Force normal is the force of the plane onto the pilot, pushing upwards towards the center of this loop. And then this arrow here is not actually a force indicator. It is a velocity indicator showing that 140 meters per second is the speed of the plane tangent to its path. And the radius here is 1 kilometer. So the only two forces actually are force normal and force gravity. But these do not actually matter because we are looking at the resultant force. And the resultant force is the net force. Net force is given in this equation. Force centripetal equals mass times velocity squared over radius. So all we need to do is plug our numbers in to this equation. We get the answer, and that should be the net force. So we will do 70, which is the mass of the pilot, times 140 meters per second squared, the velocity, over the radius, which is 1 kilometer. That converts to 1,000 meters. We do that, we get 1372 newtons. The answers are in kilonewtons, which means we have to convert. 1 kilonewton is 1,000 newtons, hence the prefix kilo. And so we divide this number by 1,000, which comes out as 1.372 kilonewtons. That is our answer, but we have to round up to 1.4, which is C. Therefore, that's our answer right here, 1.4 kilonewtons. So to recap, all we have to do, figure out the free body diagram, just so you know the velocity, any forces that might have an effect, and the radius of the circle. In this case, we do not care about these vectors because we have all the numbers we need to plug in and solve for force centripetal. And that's it.